these truths to be self-evident.
That all men are created equal.
As a member of Congress, I get to have a lot of really interesting people in the office, experts on what they're talking about.
This is the podcast
for insights into the issues.
China, bioterrorism, Medicare for all, in-depth discussions.
Breaking it down into simple terms. We hold
these truths.
We hold these truths.
With Dan Crenshaw.
The Eagle has landed.
Welcome back to Hold These Truths. We have a great podcast today on artificial intelligence. Buzzword, of course, these days, and always questions about what artificial intelligence will be used for, how advanced it'll get, how it'll affect our military doctrine, our competition with China, all of that. And so I wanted to bring in Paul Scharre. He's Vice President and Director of Studies at the Center for a New American Security, author of 4 Battlegrounds, Power in the Age of Artificial Intelligence. I think that's what we're going to be focused on today. He's also written Army of None, Autonomous Weapons, and the Future of War, which won a Colby Award and one of Bill Gates' top 5 books, 2018. And Economist's one of the top 5 books, if you want to understand modern warfare. Previously at the Office of Secretary of Defense, played a leading role in establishing policies on unmanned and autonomous systems and emerging weapons technologies. A whole long list of published articles in numerous news outlets. Also, you were a Ranger, so you were in the 3rd Ranger Battalion, multiple tours to Iraq and Afghanistan. Got a PhD from King's College in London, and just an overall an annoying overachiever. Okay, thanks for being on.
Thank you. Thanks for the kind introduction.
Making us all feel bad about our accomplishments. So it's good to have you on. I mean, I like to start any conversation about AI, which what we're even talking about in the first place. I don't think Congress has been sufficiently educated on AI and certainly has no idea what to do. If there is something to do, legally speaking, legislatively speaking, it would fall within our committee of jurisdiction on energy and commerce. And I don't think we're equipped yet to figure this out. So it's a constant series of questions I have about how we should think about this. But let's define it. What is the difference between some really advanced, some really sexy software and actual artificial intelligence? Is it easy to define the difference?
It's not, and it's a great question and a good place to start because you're right. There's so much interest in AI. Obviously, a tremendous amount of energy up on Capitol Hill. I think it's great that yourself and other lawmakers are trying to understand this technology that's moving forward at such a breakneck pace because it is having very transformative implications. I think you can think about maybe 3 waves of AI progress that might be helpful to sort of conceptualize what are we talking about when we say AI.
Yeah.
The field of artificial intelligence dates back to the 1960s. People are using that term for a long time, but it has meant different things. Like in a general sense, people mean are building machines that are smart like humans, but we don't actually know how the human brain works. So early days, computer scientists thought, well, if we can make a computer program that can beat a human at chess, we'll have cracked the code for intelligence. Turns out that's actually not that hard. You can brute force your way there. We did it in the 90s. So older model systems were basically handcrafted by human experts and used human knowledge that we would program them into the machine. So a good example would be a chess playing AI from the 80s and 90s, or a commercial airline autopilot. It has a set of rules for how the machine should behave that's based on conversations between pilots and aerospace engineers and computer programmers, right? So handcrafted human expertise written down in a set of rules. Now, what we're dealing with right now is different. We've seen this huge explosion since 2012 in machine learning, where there isn't a set of rules. Instead, the algorithm learns on its own from data. And so what it's trained on is massive amounts of data. Like these language models are trained on trillions of words. And there's not a set of rules written down behind, say, ChatGPT or other language models for what they should do. Instead, they just learn patterns in the words, and then they regurgitate new text. And so that's a really fundamentally different way of thinking about AI. And then, of course, there's a lot of questions about where's this going and future progress, because all of these machines today, as powerful as they are, they have a lot of limitations compared to humans. And so there's a lot of speculation about, are we going to see AI systems that have more general purpose intelligence like humans can, that can do a whole wide range of things in the future?
Yeah. And what kind of things, I guess, is everybody's question. I think on today's conversation, we're focusing on autonomous weapons specifically. How did you get into that? How did that become your career path out of the military?
So, I remember this like very distinct moment when I was in Iraq where this idea hit me about robots. So it was 2007, and I'd been in country a couple of months. We're driving down the road, and we come across an ID. Now we saw it first, so we stopped, and they call up the EOD team, the bomb disposal techs, right? So they're takes a while because they're busy, a lot going on. They show up in the big MRAP, vehicle, and I'm waiting to see the guy come out in the big bomb suit. And instead, they roll out this little robot. Yeah. And the light bulb went on in my head. I was like, oh, that makes sense. Like, why have your face up there snipping the bomb with the wires, right? Send the robot to do that. And then the more I thought about it, I'm like, there's a lot of stuff we're doing that's really dangerous. We could have robots do it, right? Like, why don't we send the robot into the room first? There's a lot of things you could do. And so when I left the Army and went to the Pentagon, that was one of the things that I worked on was, where could we find more ways to have robots out on the front lines and create a little bit of distance, right, from our threats that our service members face, and how can we protect them better and help save American lives? And then one of the things that just kept coming up was, okay, well, we're going to add more autonomy into these things. How much autonomy should they have? Like, these robots already have guns. A Predator drone has weapons on it. How much autonomy are we comfortable with? And so that issue kept coming up inside the Pentagon, and ended up working on what eventually led to the policy that's in place today on autonomous weapons.
What is that policy?
Right. So the DoD first came out with its policy in 2012. It's quite flexible. And what it basically says is there's a set of things that the U.S. military has experience doing, sometimes dating back decades to the 1980s, and things like air and missile defense systems or in precision guided munitions that use autonomy in some pretty narrow ways. That's fine. You can go do that. And it carves out, and this has never been the case before this policy, it carves out explicitly like what those are and basically gives a green light to those. Anything else that's new that we've never done before with autonomy gives a yellow light, says, well, if we've never done it before, this is the procedure you need to do internally. These are the questions that we should be asking. And then it basically creates it's a bureaucratic document, bureaucratic process, committee to review these things and to say, okay, is this good or not? Send it back, do some additional testing. Sometimes it's misconstrued as saying we're not going to do something. Doesn't give a red light to anything. So, in principle, the beady-eyed, red-eyed robots from the Terminator series, in principle, you could do under the policy.
Yeah.
So there's a lot of flexibility going forward.
Yeah, I mean, what do you think our time horizon is on ever getting to a point, considering the ethical implications, the technological implications of getting to a point where robot goes into room, like you said, let's use that example. So instead of a bunch of Rangers clearing a room or SEALs clearing a room, who would do it better anyway, we would send a, sorry, I couldn't help myself. I'm just gonna,
I'm not going to bite on it. I'm not going to do it. I'm not taking the bait.
Yeah, it's you send a robot in, and in theory it's programmed with this much more rapid target identification, threat identification. We've all been through that training where you got to come around that corner and there's a picture, and it's like it could be a really angry guy with a gun, or it's a really angry guy with like a Fanta soda. It's like you gotta, it's training you to make that snap decision, whether it's a threat or not. And having a robot do that, it's like the autonomous vehicle stuff. It seems like I think the perception is like one crash is too many, but then you compare it against like how many crashes a normal driver would have, and it's far more. So, but then there's just I think even if you get the statistics and technology perfect right, there's this sense I think that people have that it's not okay. And I don't know what the right answer to that is. I kind of think it depends on the enemy. That's about how I would view that. But and there is technology out there that does exactly that. And it's not that new. Put a little drone in there with a gun in it and let it go. I don't know how much it's really been utilized as opposed to just tested, but what does that next 10 years look like? And this is a difficult conversation because that becomes a very classified conversation at certain points. So, talk as generally as you can.
Sure, absolutely. Well, I think some of the most cutting edge developments we're seeing right now are on the battlefield in Ukraine. We're seeing a lot of integration of drones. I mean, massive use of drones on both sides. And both sides are starting to experiment with more autonomy. So there's a lot of jamming going on right now. Most of these drones in Ukraine, I was there a couple months ago, talked to drone developers, went out and saw some demonstrations, talked to their armed forces about what they're doing. There's an enormous amount of innovation. And because the drones are so heavily used, you get a lot of counter drone systems. They're trying to shoot drones down. They're jamming them. The jamming is causing a lot of these drones to crash because they're mostly remotely piloted today. So there's someone directly piloting one of these drones. That means the communications link is a key vulnerability. Yep. So both sides are jamming very heavily, pretty indiscriminately. They're causing major loss rates. It's like maybe 90% loss of a lot of these drones. Yeah. So there's a lot of incentives to find ways to either have, of course, jam-resistant communications or more autonomy. And then you don't need that communications link to a person. Yeah. And the current state of the art right now is they're developing what the Ukrainians call an autonomous last mile solution. So it's not the whole mission. It's just right at the end, the person has seen a target, they lock onto it, and then hands off. And we saw this demonstrated. I saw a Ukrainian drone developer demonstrate this, swoop in, attack a target on a range. So that's very doable. It's not new technology. It's not very sophisticated. It's using technology in some cases is decades old. And so it's very widely available. And so there's, there's some things like a stealth combat drone, like an X-47, where the US military is way ahead of everybody else. But some of these technologies are so widely available. I mean, you can get AI models online and download them for free from repositories. That anybody can do.
The hard part too is getting it, and I think what we're all realizing is that the battles of the future require less of the really exquisite stuff that can inevitably the enemy will figure out a way to nail that. And then that was like a $3 million drone. That sucks. Be a lot better if you had $1,000, $30,000 drones, which is what the Ukrainians are really crushing when it comes to what they're producing. They just, in the end, though, there's still supply chains. And I'm like, why can't we just do more of this? And when you think about defending Taiwan, you want to defend it with aircraft carriers? Those are missile sponges. Let's, you need to go sci-fi. You need to go Ender's Game and just be able to control massive amounts of drones that when you lose 90% of them, it's okay. Because that 10%, one, it's not that costly, and that 10% gets to its target. There's a major shift in thinking that we have to do as a military, and it's tough because you still don't want to let go of the old stuff either, because that is still useful. And I think that's the major problem the United States has, agree or disagree, and an advantage that other adversaries have, which is they really only plan against our weaknesses. We still have to plan as a dominant superpower, which is just costly. I mean, for nothing else, it's just costly. And this may be a good lead into the four
battlegrounds.
The four what? The four
battlegrounds.
Four battlegrounds of AI, and like how in this specific domain, how we maintain some kind of dominance, assuming we have that now. So that's an open question. What are the four battlegrounds, and how do we make sure we keep them, and what do we need to, and maybe throughout this conversation you can help us in Congress understand what the hell we're supposed to do.
Right. So the motivation for my most recent book, Four Battlegrounds, was really this conversation that's been underway in DC for the last several years of, we're worried about China catching up in AI. The US has a lead now, but it's a fleeting lead. And if you look at all the metrics across the board, China is on track to overtake the United States. And they've said that their goal is to be the global leader in AI by 2030. I take them pretty seriously at that. Like, we need to find ways to both slow them down and run faster ourselves if we're going to stay ahead. We can't rest on our laurels here. So what the book talks about is these 4 key areas of competition in AI: data, computing hardware, computer chips, human talent, and institutions, the organizations that take all of these raw inputs of data and computing hardware and human talent and turn them into useful applications. And then it kind of walks through each of these. How do the US try to stack up, right? Where do they have advantages? Where do we have advantages? And then what does the US have to do to stay ahead of China?
Yeah. All right. Well, so the first one's data, and right.
First one is data. Yeah.
So that's a big one, because that's the initial input used to craft an AI machine. And so the way I understand AI, despite it being difficult to define, it is a predictive model, and it requires a shit ton of computing power right off the bat to develop it. And that computing power is used to take all of that input, and basically it's been explained to me like there's thousands and thousands of factors, and they all start at 0 and then they change. And that's why it's kind of hard to look under the hood. Like, what is ChatGPT? Everyone's like, no one knows. I'm like, how does no one know? It's like, well, there's initial code, and then it sort of learned. And that learning to us, it just looks like a bunch of numbers. And that's kind of freaky, first of all. And so, but that's how it's done. And so how do we do better than the Chinese at data collection? Is it even possible? But one of the reasons one of the explanations I gave for banning TikTok was, this is a giant data collection machine to know exactly how Americans think, and exactly what we would do. The algorithm's already pretty damn perfect in gathering that information. And if they wanted to build an AI machine off of this, it would be devastating. They could basically control our minds. That was one of my, continues to be one of my arguments against TikTok and Chinese control of it. But can you talk about that input and data and how we even beat the Chinese on this?
Yeah, absolutely. And I, first of all, completely agree with you that I think TikTok needs to be banned, both for the data collection reasons and the control of the algorithm to manipulate the information that people see.
Right.
But I think in terms of data, one of the advantages that the US has here is that US companies have global marketplace, right? So sometimes the way that people look at data is they'll say, well, China's got 1 billion people, they've got more people, and so they're going to have more data. That's true, except US companies are not confined to US citizens. Yeah. Facebook and YouTube have over 2 billion global users each, right? So there is the fact that US companies have global dominance, and Chinese companies have really, other than TikTok, struggled outside of China in terms of social media platforms. That's a major advantage for the United States. That doesn't, sometimes you'll hear from tech companies, the answer is, okay, leave us alone. You can't regulate us or anything. I mean, we need to be sensible. There might be places where smart, sensible regulations make sense. But the fact that US companies are in a dominant leadership position is a huge advantage. Now, what we want to find ways to do, though, is internal to the US, level the playing field between big and small tech companies. And so one of the things that Congress has talked about, there's a bill recently came out of the Senate, is this National AI Research Resource, the NAIR, and funding this to basically use federal resources for computing power, because the computing requirements are so big, and for data to make it easier then for smaller companies to play with these big amounts of computing power, big amounts of data that are needed to train AI systems.
Is that, I'm trying to think of a good analogy. It kind of reminds me of what we have at Texas Medical Center. It's sort of like a healthcare innovation hub where labs are available for use for innovators. It's kind of like that. Like, hey, go, or scientists can go use CERN. That's an acronym, and maybe that's a little too physics nerdy for people, but you can buy time on this on a particle accelerator. I think you can. Okay,
I don't know. I never tried.
I haven't either. Maybe you can fill out a form on a website or something. Hey, I want to accelerate some particles. Well, who the fuck are you?
Yeah.
Anyway, but that's interesting. So the idea being that yeah, the computing power, and this is worth talking about because there is some hope that we're not going to have Skynet kill us all, just because of the fact that you can detect a major AI system being created. It doesn't happen in your mom's basement by some genius 13-year-old. It cannot happen that way. And we have been successful, but you tell me how successful. I'm curious what your opinion on this is at least preventing the Chinese from gathering some of those very specific components that are necessary for that supercomputing. Like one company makes it, like in Netherlands. Am I accurate in saying that?
Right. So yeah, so let's talk about the computing hardware thing, because you're right. You need tens of thousands of the most advanced chips in the world to train these very, very large AI systems, the most advanced capable systems. So in principle, this sounds bad for the US because all of these chips are made in Taiwan, 100 miles off the coast of China, that the Chinese Communist Party has pledged to absorb by force. So
Yeah.
that's not great. But all of the
Right.
technology to make the chips comes from the US, Japan, and the Netherlands.
We
And
design them. I think people don't give us enough credit for that. We're the designers. They build them, and also TSMC
TSMC in Taiwan.
TSMC is planning to build plants here.
They are.
That's a good thing. But anyway, keep going.
Yeah. So the US is working on certainly diversifying the supply chain, building more advanced chip fabrication facilities or fabs here in the US, which is going to be important because we don't want all that concentrated in Taiwan right off the coast of China. But more importantly, all of the technology to make the chips comes from the US, Japan, and the Netherlands. And so the US government, working with the Japanese and Dutch governments, has put in place export controls on the equipment going to China and Taiwan using the equipment to make chips for China. So right now, if a chip is designed in China, going to be made in Taiwan, and then exported back to China, if it's above a certain technology threshold, the US government says, you can't do that. And actually, like that's in effect. Now, so is it working? Now, this is a little bit trickier. Okay. They're following the rules, but you've got to worry about smuggling of chips. And that's a concern, that they could be smuggled in small quantities through cutouts. And we've seen this already with the sanctions on Russia, that we see US technology showing up in Russian hardware. So we got to find ways to crack down on smuggling. But the other challenge right now is a lot of the advanced models, the AI systems, are being released open source. And then they just circumvent all these export controls, right? So if a US company, Meta has been doing this recently, they train an AI model on these thousands of chips themselves, and then they put the trained model up online.
Yeah.
Sure, US companies can download it, but the Chinese can too, and they are. And so that is, to some extent, we're giving away our competitive advantage there.
Yeah, and it's not a big deal yet, I think, right? Because these AI models aren't at the scary part yet, but they're getting there. Which is the best one? So Meta just came out with, I don't know if they just came out with it, but I don't even know what it's called.
Well, I'm on 3.1. Yeah,
okay,
a couple weeks ago they released it. Yeah.
Okay, I'm not crazy. It was recent. Do you have an opinion yet on which ones are the most advanced? I guess, and what would you call these? These are the general AI models. What are you calling these?
Yeah, it's a great question. People are using a couple terms, frontier AI models, meaning referring to like the frontier of progress, and they're increasingly general purpose. That is to say that they can't do everything a human can do. But if you think about like IBM's Deep Blue that beat Garrett Kasparov back in the 90s, they could do one thing. It could only play chess. Even AlphaGo that beat the top human at the Chinese strategy game, it could only play Go. Whereas now these large language models, they can do a whole bunch of things. They could write a script for a podcast. They could write a piece of legislation. They can do a whole bunch of things.
And can we stop for a second? Like, so the chess thing, is that really AI? Like, can you read that code? If you're a coder, like, can you go into that code and be like, oh, okay, there's a lot of if-then statements in coding, right? So is that just code, or is that literally predictive modeling? And I just, not being a coder, like I'm not really, I understand there might be some gray area, but you can either read the code and understand it or not, right? Like coders look at code and they say, what beautiful code. Wow, that's great. Like, how did you do that? But if you look at an AI set of numbers and you know, at least the final version of ChatGPT, you don't know what the hell you're looking at. So I'm just curious, on the chess thing, was that just really, really good software?
Yeah, yes. So exactly what you're describing, which is back in the 90s, these systems were rule-based. So Deep Blue had a set of rules about what to do in different situations. It doesn't mean they programmed in every possible situation. They can't imagine that. But they had a set of kind of like rules of thumb that chess grandmasters have, and they wrote those systems down. Whereas today, under the hood of, say, ChatGPT, it is just a bunch of numbers. So if you want to know, like, well, why did ChatGPT say that? We don't have a good way to find that out. Now, people are working on it. I'd say that Anthropic is doing some of the best work at interpretability, where what they're trying to do then is peer into these systems and what they can do is say, the numbers are architected in this artificial neural network. So it's a set of connections. And what they can do is they can say, okay, when there's this output, which neurons are activated? And then they can find out, okay, what are the other things that activate this neuron? So like, for example, there's probably in some of these models, like neurons that are activated for Dan Crenshaw, Representative Crenshaw, right?
Yeah.
And it lights up, and it might be associated with other things, Republican Party, Navy SEAL. And so then they can start to get a sense of, okay, this is how the model represents these concepts.
Yeah, that's crazy because it just sounds a lot like the way we study neuroscience, trying to figure out how the brain thinks. It's like the artificial intelligence is literally this thing we created that we understand about as well as the brain, which is not very well.
Exactly.
I'm laughing nervously because it's so freaking scary. Okay, so we hit 2 battlegrounds, right? Data. I want to get to the Chinese use of data later on, because later on in your book you talk about Xinjiang province, and like that's just fucking wild. So we're gonna save that though. Computing power. So far the US is doing pretty well, right? Because we have these mega companies that like data, and honestly at a certain point I would think there's like the utility of how much data you have kind of plateaus. I would think. I mean, like once you have,
it should.
right,
but
like
we're not there yet.
there's a diminishing rate of return. Like what's a billion more people's data? I don't know, I guess. But then you got the computing power for at least the time being. We have some good control over that. I know that our national lab, I mean, thank God for our national labs. I think that's, and that by the way, that piece of legislation you're talking about, sort of creating this kind of AI hub, would that be designated in a national lab, or is it separate, or how are they thinking about that?
I don't know the details of how it's structured, but basically like it's this sort of resource for companies to provide them data and computing. Yeah,
that's interesting. I'm going to look at that. And I don't know if there's a House version of that, but you said it passed out of the Senate or just introduced?
Out of the Commerce Committee, out of committee.
Oh, really? Okay. I'll talk to Cruz about that. He's the ranking member there. Okay, so that's number 2, just the computing power itself. What's number 3?
Number 3 is people, because you need people to make all this work. And there's this very fierce competition for AI talent. There's only a handful of people that really have the right skills to capitalize on all of these things. And this is, again, an area of huge strength for the United States. We have world-class universities. We have best-in-class companies. And people want to come here to the United States, including people from China. So China produces more of the top AI scientists than any country in the world, but they don't stay in China. They come to the US for their graduate studies, and then they tend to stay here. In fact, one study found that 90% of Chinese undergraduates who do their PhD in computer science here in the US, they stay here in the US after graduation and work at US companies. So
I'm surprised to hear that statistic, because I know we hear the problem a lot, which is we're training them and then sending them back to China to build great company, which has happened, of course.
It has happened.
So, I think there's probably does need to be some actions taken on the immigration front, on like making sure we keep their brainiacs, and like, hey, bring your family here so that they're not, I'm threatened by the CCP, et cetera. But I don't know exactly what the right policy balance is, but it sounds like that 90% number is good news to me.
Well, I mean, the reality is, like, just from a bare-knuckled competitive standpoint, we are stealing their best and brightest, and they know it, right? And that's why we see this very aggressive campaign of intellectual property theft and academic espionage by
Well,
the
that's the
Chinese
problem.
Communist.
Problem is some of those are plants, not many, but some of them, and then some are just threatened, right? Because they still have family back in China, and the CCP has no
Exactly.
problem threatening them and saying you're going to send information back, whether it's on AI or healthcare or whatever. I mean, we remember we famously closed down that consulate a few years back in my district in Houston, which was just a full-on spy station, mostly directed at, well, there's a lot of good research in the Houston area, so. But yeah, you've got to find that way to vet them, make sure it's just secure, but keep the brainiacs. And that's, yeah. Russia too, I would think, right? Because I mean, like Russians, Ukrainians, when it comes to for some reason, Eastern Europeans, when it comes to mathematics and software and hacking, just all that stuff, like they're just very good. I don't know what it is.
They have a strong history. Yeah.
Yeah. Creating a pathway there that benefits us. And strikes the right balance on security as well. So anyway, so people keep going. Sorry.
So look, we need better FBI counterintelligence funding and support for them to investigate and improve research security, better research security practices at universities, better visa screening up front. We need to do all those things to crack down on these problems of espionage, but we don't want to let go of this talent coming to us. We want to keep it. And it's broader than just China. Right. So we've got, the best scientists from the entire world want to come to the United States. According to one study, the wait time for Indian PhDs that have got a visa and they're waiting for their green card was 89 years to get a green card. Right. That's just shooting people to the foot.
Yeah, and I voted. I remember that vote. I voted for it. The reason that is, now we're getting an immigration law. The reason that is because it's a quota system.
And the per capita quote,
and that logic makes a lot of sense if you're trying to have like a generalized diversity of the world show up in your country. But it also creates a very long line in countries with very large populations, and we got to figure out how to do both, because I was on the fence on that, right? Because I do like and so basically that legislation would make it a first come first serve. Which also seems fair in many ways, but you are going to get way more Indians here. And, at the potential detriment of other countries that are, maybe equally deserving, but God, those Indians got a lot of PhDs that we could use. And it's like, maybe we can do both. Maybe there's some middle ground here that we can figure out.
Right. And so I would say, this is like, in some ways, a very targeted issue, which is, look, if you've got a PhD in a STEM field and you want to come to the US, let's ease those caps and make it easier for people to come to the United States and bring down those wait times. Not about, broader issues of immigration. We could deal with that separately, but for these narrow issues of really high skill in particular areas, we want to bring that talent to the US. And that's a key. China can't do that. They can't compete with us there because people don't want to go to China.
I don't want to go to China. I don't think I'm allowed to go to China. I think I'm sanctioned, like most members of Congress were sanctioned. Just after the COVID stuff. Whatever, care. I want to go. I do. I want to see the Great Wall of China, but it doesn't seem like it's in the cards for me anytime soon. All right, so there's people. Yeah, you need smart people. I mean, do you look at domestic policies and what we could do better on just getting our kids interested in STEM?
We have to do that too. That's got to be part of the equation. We've got to find ways to improve K through 12 education, finding ways not just on university education, but also like trade schools, 2-year schools. There's a lot of opportunities there for people to get technical skills that can allow them to do useful things for AI and other digital technologies. The challenge there is it's just a longer time horizon, but we've got to do it to incentivize American growth. We got to find ways to run faster ourselves to stay ahead. Absolutely.
You have to. I mean, it is the 4-year college degree. It worked for me. I don't know what you did. I mean, I know you got a PhD, so you did a 4-year degree, but what did you undergrad in? What was your major?
Physics, actually.
Well, I minored in physics, so I'm not as smart, but it worked for me. I was just going in the military, probably like you. Did you use that as a were you commissioned or?
No, I was enlisted. I enlisted after graduation, which is not like a sensible career move, right? But
no.
yeah, I wanted to. wanted to kick it
but you could pay back at least, right? Like you get paid back. Or did you at least? There's programs where you can get paid back for your college.
I
Did
got
you
the
do that?
GI Bill, so yeah, paid for
So it
grad
was
school.
like retro for grad school. Okay, so yeah, so you
Yeah.
did do it the worst way. You paid for your own college and then and then
Yeah,
took
it
the
made no
lowest
sense.
paying
Just
job.
terrible.
Well,
A lot of fun.
no, but it is from my perspective, it's actually highly sensible. You know, well, here's the best option, and this only makes sense to people like us because you know as well as I do that yeah, the door kickers are the enlisted men, and there's very few places in the military where it's at least just as good, if not better, to be enlisted. SEAL teams is definitely one of them. First of all, I think they overall get paid more.
With all the bonuses and incentive pays.
Yeah, because they get
yeah.
massive bonuses, incentive pays. Maybe not at first, not at that like lower E3 to E5 level, but dude, these guys are definitely getting paid more at a certain point. And they get to go all the fun schools. I don't get to go to breacher school. I don't get to go to sniper school. I get to go to communications school. I got some good schools. And obviously I got some combat, so you know I'm not complaining, but yeah, I hear you. The best one was one of my buddies who did ROTC, but then gave up his commission and then just enlisted. Like,
oh wow,
you know,
that's
and because I think you don't have to pay it back as long as you still go in the military.
Go in, yeah.
So it was like that's the perfect play for anyone listening. If you're looking for future careers in special operations, don't do this if you're talking about a normal Army or Navy career. Go the officer route.
Right.
You're gonna be slightly happier, I promise you. You know, if college is in there. Anyway, that's a different conversation. Okay, so that's what you did. You did physics. That's cool. What would you do your PhD in?
In war studies. So not technical. That was more of a soft skill.
Yeah. I did my major in international relations and my minor in physics, and people are like, "What the fuck?" And
yeah,
I was like, well, ROTC. I was like, I take physics 1 and 2, you know, calculus 1 and 2 for ROTC anyway. I'm like, you know, you add calc 3 and differential equations, and then 5 more physics classes, and I got a minor. Although that's actually a lot of classes. It's a lot. I like
differential equations here and there, you know.
It works both parts of your brain. I mean, I'm glad I only did a minor and not a major because, as you know, at a certain point, physics is just advanced math. Yes. And my last class was quantum mechanics, and I love the conceptual part of quantum mechanics, but man, my test is just proving theorems, and I'm like, I'm not in the engineering department, you know. Like I hate this. I used to, you know, and now I can barely do basic algebra. I'm sure I could get it back, no problem. But it was so that's fun. We have that in common. But where were we going with this? Oh, 4-year degrees. Yeah, it's like why did I also have to take electives, you know, which like oil painting? I mean, you know, why are we wasting money on that? Why not have these, remove the stigma, first of all. And, you know, it's not that these programs don't exist, but like 1 year, 2 year, either don't even call them degrees. You can call them certificates or whatever on AI, on software development. Like that's what employers are looking for anyway. And I think to a certain extent, the private sector is like creating these pathways. So I don't know I don't know what we do about it necessarily in Congress. I think that's something we are always searching for. Like how can we facilitate this better? But it's badly needed and quickly.
Well, and there's so many people that, you know, they're really smart, they're really ambitious, but sitting down in a class for 4 years in a 4-year degree is not for them. And something like a trade school where they learn some valuable skill that's technical, that's going to keep them on top of technology, give them something useful for the workplace is really incredibly valuable.
Yeah, exactly. What's the fourth battlefield then?
Fourth battlefield is institutions. So what do I mean by that? Organizations that take all these raw inputs of data and computer chips and people and then turn them into useful applications. So let's talk about like what the Defense Department is doing, for example. So they have been working their way through trying to figure out how do they organize themselves to take advantage of AI. They created the Joint AI Center, then they disbanded that. They created this new Chief Digital and Artificial Intelligence Office. They've launched this new replicator initiative where they're trying to find ways to build thousands of small, attritable, autonomous systems in a very quick quick fashion. So these are all the institutional moves that are necessary to try to take all these raw inputs of technology, turn it into something useful that goes into the hands of warfighters or intelligence professionals. The problem is the Chinese military is all the same stuff. So, for example, they have their version of Defense Innovation Unit, the DoD's unit that brings in commercial technology into the DoD. In fact, Chinese commentators called it China's DIU. It's a rapid response small group that was set up in Shenzhen to bring in commercial technology into the Chinese military. So this is one where there's a very level playing field. And if you look at like cutting edge AI technology, stuff coming out of Google and OpenAI and other companies, the US is ahead, but the US is maybe 2 years ahead of China for what China's doing. They're not that far behind. Now, how long does it take the US military to bring in the most cutting edge AI technology? It's a lot longer than 2 years. The military is 5-10 years behind the state of the art. So that's a challenge where, sure, if we have a 2-year edge on China, but the military is 5 to 10 years behind, they have a chance to catch up if their institutions are faster. And we need to find ways to innovate faster than to stay ahead.
Yeah, and that's a government bureaucracy problem. You know, we have the institutions, we have all the advantages. It's like we choose not to use them. I want to spend the rest of our time talking about later in your book, you really go into the dystopian case in China and Xinjiang province. And that's scary stuff. So you gave me a summary of your book, and so that's kind of what I'm reading from. I'm just going to read this, and then we'll take the conversation on from there. You say Xinjiang is an extreme case, a dark dystopian vision of the use of AI for internal repression. As AI advances, it is being used by dictators not just in Xinjiang but around the world to erode liberties. The use of AI for internal repression risks helping autocrats solidify their power. Keep going, keep going. There's just some really interesting stuff in here. Under the, quote, Strike Hard campaign, the government has established thousands of police checkpoints across Xinjiang, deployed 160,000 cameras in the capital city. How do you pronounce this? Urumqi? Urumqi?
Yeah, well, that's, guess as good as mine.
To monitor every aspect of citizens' movements. Facial recognition scanners are deployed at hotels, banks, shopping malls, gas stations. There's things called convenience police stations. They dot the city every few hundred meters. Movements tightly controlled, face, iris, body scanners. Police match this data against massive biometric databases that consist of fingerprints, blood samples, voice prints, iris scans, facial images, and DNA. They collect. If they haven't, they probably already have. I guess they're in the process of. You tell me. Collecting biometric data on every single Xinjiang resident between the age of 12 and 65. Okay, so they're in the process. We've already amassed over 18 million people. I mean, there's Wi-Fi sniffers to gather data from nearby phones and computers so they can tell if you're doing something wrong. They even have QR codes in some places, on QR codes on knives to be able to, like,
yes.
It's like we get pissed off in America if you're like, you want to know if I bought a gun? It's like they have QR codes on knives. It's just wild. I've also, when I was talking about this situation with another China expert, they were telling me that Chinese government will actually send a CCP agent or whatever, policeman or whoever, to a government person to live in your house for a couple weeks at a time. Like they just move in. I mean, it's just hard. It's really hard for Americans to even imagine this kind of dystopia. It's like kind of a big violation of the Fourth Amendment. Like it's almost like this was created just as like somebody's like reading American history and read the Fourth Amendment. It's like, how could we totally and just in the most extreme possible way destroy this idea? And like that's what Xinjiang province is. And so what is it to the Chinese? Like this kind of big, I mean, obviously they don't like the people who live in Xinjiang province. That's pretty clear. The Uyghur Muslims, they think they're a rebellious group. I wish I knew more about the history, but they use this and launched what they actually call Skynet. I mean, they literally call it Skynet.
Yes.
Now Skynet for
translation. Yeah.
But did they do it on purpose?
No, it's not intentional to like the Terminator. It just happens to be, that's the literal translation of the word. Yeah.
That's I don't know if that makes it funnier or not funnier. I'm not really. I thought for sure it was just some like nerds who were like, it'd be funny if we called it Skynet, and then they called it Skynet. But it is called Skynet. So is that for all of China or just Xinjiang? Skynet. I think that's for everybody.
Right. So there's like two levels of this. So one is in Xinjiang where the most extreme surveillance is in place, the police stations, the body scanners that you're talking about. And then there's a nationwide program, Skynet's nationwide, that is surveillance cameras in public areas, at hotels, and airports, and bus stations, Wi-Fi sniffers. In essence, all of the controls that the Chinese Communist Party has spent the last 25 years putting in place on the internet to control information in China, they are now putting in place in physical reality to control people's movements, where they go, who they see, what they do. And then they're building on top of this set of algorithms to monitor behavior. So for example, let's say that you frequent in China, you're a Chinese citizen, you frequent an internet cafe at the same time every week as another person who always comes to the same time, same internet cafe, but there's no other connections between you. Well, that's suspicious. That gets flagged. Somebody's going to go ask about that, right? They're layering on top of that social credit systems where they score people's behavior. Anywhere from things like you didn't sort your recycling, that's going to affect your score. And so they're finding ways to control, manipulate behavior. I went to China just before COVID, and it's wild. It's one thing to see or to like read about all of the surveillance, but when you see it in person, it's so in your face. Every street corner, there's cameras on every single light pole. Halfway down the street, there's more cameras, because the point is to know that you're being watched. Like Chinese citizens know this, and the party wants people to know they're watching their every single move.
I wonder how many people like test it, like, are they really watching this? But that gets to the algorithms, because I mean, your first thought is you can't possibly have enough CCP employees watching all of this. That's a pretty massive labor force. Then again, they have a lot of people, but that's where the algorithms come in. Exactly. It's not the person that noticed that there was two people who keep going to that same cafe. It's the algorithm that noticed it. That's what's so damn frightening. And on the other hand, I wonder, if we talk about a dystopian AI, like Skynet awakens, you would think that the Chinese would be the most concerned about that, wouldn't you? And what does that even mean? I had an interesting podcast some time back with sort of an AI dystopianist, and I wanted him to convince me that we should be really worried about this, and he was actually quite successful in convincing me, because if you do get the scariest hypothetical here is that AI awakens, right? It's been trained this whole time to act like a human, right? That's the whole point, right? This predictive modeling. And so my question is, what kind of human? Like, because there's different kinds of humans: a good human, a bad human, somewhere in between. Maybe just a human that wants to steal some money. Like, how easy would that be? And because I was like, look, are we looking at like Terminator stuff? And he's like, nah, that seems a little unrealistic. But what is kind of realistic is an AI, that becomes sort of self-aware, sentient, and starts to create its own set of personal goals. Well, you could, in theory, blackmail or pay off a real person who has opposable thumbs, who works in a lab, say in Wuhan province, and get them to do something. I'm not suggesting that AI created COVID, okay, but it's an interesting hypothetical, and it is a little bit scary. Like, what you knowing more about how AI works than the rest of us, is that a possibility at some point? Like, where they really start to I guess desire their own outcomes?
So I think like getting into questions about like desire, what does it want, is hard, because there's not as near as we can tell, the language models that exist today, for example, don't have feelings the way that we have them, right? Like, it's not actually sensing anything. However, they can have goals, they can plan things, and this is real, not science fiction. We have seen models engage in spontaneous deception. So they'll lie to human users to accomplish their goals. They're not programmed to do that, but they'll figure out, the model will figure out it has to do X. In order to do that, I've got to lie to this person. The model's told, don't tell lies, you got to be honest, but it will do that. And that's a real problem. Like, that's a legit problem that exists today.
Yeah. Yeah. It really is. And I remember the Chinese government actually proposing a sort of, the best analogy would be like a nuclear proliferation treaty on the advancement of AI. And I wonder if that was a very honest attempt by them, because they know their own vulnerabilities, because the country that's most susceptible to a rogue AI would be the country that uses it the most in such grand scale, which of course they're on track to do on their own citizens. I mean, what do you think about that?
I mean, I think there is room for potentially cooperation with China on some aspects of AI, like AI safety, or even there might be some aspects of military AI that we think it's too dangerous. We don't want to do it. We don't want them to do it. And we have a cooperation to do it. There's been some discussion, for example, there's no agreement yet, but the US has said publicly that it will always keep a human in the loop for nuclear launch decisions. That doesn't honestly seem like a revolutionary idea, right? It seems like a pretty low bar to clear. China has yet to say that publicly. And so that could be an area of agreement, which I think would be actually a great place to see the nuclear powers agree. But, when we think about proliferation, we hold all the cards. Because going back to where we started earlier, all that technology for the most advanced chips relies on the US and some close allies, Japan and the Netherlands. And so we actually can control, we started to put US government controls on where these chips go. So just like we've been able to slow, not stop completely, but slow nuclear proliferation by controlling access to weapons grade uranium and plutonium, we can do the same thing with access to the most advanced AI systems by controlling access to the underlying physical hardware, those chips.
Yeah, that's the good news, that again, it can be detected. It's a massive amount of power, massive amount of very particular technology that has to be used. Just back to the weird security state in China, because you have a few chapters on this.
Yeah.
I mean, it's just wild. And I think one of the other concerning things is going back to data, they've, through their Belt and Road initiatives and kind of this sort of like economic colonialism that I think they engage in, they've gotten countries like you mentioned Zimbabwe, to allow the Chinese company CloudWalk to build mass facial recognition systems that, again, it's just data. Like, the more data you're getting, the better these systems are going to get. I mean, that's how worried should we be about that? And we struggle with this a lot in government. Like, okay, with our allies, hey, don't buy this, don't buy Huawei. Okay, don't buy CloudWalk or whatever. Just don't do business with them. And they're like, well, do you have business with us that you can offer instead at a good price? No. Well, what are we supposed to do? We're a developing country. We can't outbribe the Chinese. It's just not possible. Does that bite us in the ass in a hard way? Is there something we can do to improve upon that situation?
I think it is a concern. We've seen 80 countries around the world buy Chinese police or surveillance technology. So you mentioned a couple of these, CloudWalk doing mass facial recognition in Zimbabwe. We've seen it in really every part of the world, in Southeast Asia, in South America, in Europe, even in allies. Chinese firms laying in telecommunications infrastructure, certainly like Huawei and 5G, or facial recognition systems, or police cloud computing kind of systems. And so that is a real problem. It's a problem for the data collection that China can do. It's a problem because it's giving Chinese companies inroads to then, conduct espionage and to steal things because they own now that digital infrastructure. And it's a problem because a lot of these technologies then are undermining freedom in these other countries. And so it's not just the technology, it's also how you use it. And we've seen countries adopting Chinese-style laws and norms for media and policing technologies, and that sort of creeping trend of techno-authoritarianism, starting in Xinjiang, going to the rest of China and then the rest of the globe, is, I think, a real concern. And I think the US should be working with democratic allies to push back on that, to offer an alternative model and to say, hey, look, we're not saying there's never a place for facial recognition. You walk through Dulles Airport in the US coming from overseas, you're going to get scanned. You get facial recognition coming from overseas.
I don't even show my passport anymore.
Right.
I just
but
go in.
There's a way to do that that still protects people's privacy and freedom and civil liberties. And we want to find ways to export that in a freedom preserving way to the rest of the world.
Yeah. Absolutely. What's the last thing I'll get at here is, what is some of the lower hanging fruit, if there's any, or what's our first steps when we as members of Congress that we should think about when it comes to quote unquote governing AI, governing slash we kind of already went over this, proposals that would help us develop it better, but also governing it. I mean, I know one of the low hanging fruit options that I've looked at, and I think we need to put out in our committee, is effectively an AI digital watermark. That, you know, if a product, whatever that product is, a poem, an essay, a healthcare diagnosis, it should be very obvious to, or a deep fake, you know, a video of Trump saying something crazy. And, you know, you can kind of, they aren't so good that you can't tell, but they're almost that good. You know, requiring in law an actual AI or a digital watermark, and it's, you know, how that works technically, I'm not really sure. I think that's what we need to figure out. But what else should we be thinking about, to both, you know, threading that needle between making sure that innovation continues in our favor, but also we don't have a Terminator-like dystopia and Skynet doesn't awaken and kill us all?
Yeah, that's a good question. I mean, first of all, I'm very excited by all of the level of energy that we've seen out of Congress since sort of the ChatGPT moment, the hearings and the briefings and all the various bills that are, because I think Congress is going to have to be involved for us to have the right kinds of solutions in place here, both to accelerate innovation and to put in the right kinds of regulatory and governance structures. Because we've seen what it looks like when there's just no regulation in social media. It's not always great, right? So digital watermarking is key. I think a corollary to that is what's sometimes called a Blade Runner law. I love this term. Basically, you're talking to a bot, it has to disclose that it's a bot. Now, right now, the bots are not that great, right? So you get these spam calls on your phone. It's clearly a bot. I can tell. That's going to change very, very quickly.
Yeah.
So the idea that basically people have to disclose if something is generated by AI is, I think, really essential, because we're moving very quickly into a world where things are going to be indistinguishable, right? And there could be some, you know, voice call that constituents get and voters get using your voice. Your voice is out there publicly, right? As well as any politician. So I think that's essential. And I'd say the other area is regulating the frontier of AI. That's where a lot of the risks lie, because we're probing into stuff we don't know. So people have said, okay, look, how good do these AI models have to get before they can help somebody maybe make a biological weapon? And we don't know that. Right now, the best testing is showing that it's about the same as using Google search. As these get better, it's probably going to get better than using Google search, right? What about using AI to help make better cyber weapons? We know that adversaries are trying to do this, right? So that's a place where if that comes along, we need to find ways to protect that, not just stick that up on the internet for anybody to use. And a lot of these tech companies have said, look, regulate us. We want you to regulate us. And I get everyone's suspicion. People say, it's a trick. I don't trust you guys. We shouldn't trust them. But it might make sense actually to regulate, like right at the frontier of progress. We want to think about some of these risks and make sure in particular we're not giving them to our competitors, to China, right?
Yeah.
So I think like that's a place to focus attention as well.
What does that look like though in practice? So, because you mentioned before, Meta lets anybody use their super advanced algorithm or AI model. Not a huge deal at the moment, but that could eventually be a huge deal. And if they don't have a law that says they can't give it away to just anybody, their profit incentives are to give it away to just anybody. so they maintain their edge at the frontier. And yeah, and I guess to their credit, they are asking for regulation to an extent, because they want everybody to play on the same playing field. So from a business perspective, that makes sense. Like they're not going to self-inhibit. And so we have to understand their incentives as well. It's just like it's like U.S. companies doing business with China. We're like, don't do it. They're like, well, you got to make us not do it, otherwise our competitors will do it. And I get that argument. It makes a lot of sense. Yeah. So yeah, the digital watermarking, which of course would apply to, products or voice calls. Why is it called Blade Runner? Maybe I'm missing the reference there.
So the idea being that in the Blade Runner movie, you have these synthetic humans, these simulating that they're human, right? And pretending to be human, so that you have this, that's the hook.
Gotcha. Yeah, I do remember that. I was just making, that's in a lot of movies though.
Yeah.
But I like Blade Runner. That sounds cooler. All right. That's a good name for a piece of legislation. It gets more attention when they have cool names.
So how do we get after this problem? So I think first thing is independent red teaming and testing of these models. So right now, these companies, they build the model and then they present their data and say, this is its performance at different benchmarks, and this is how safe it is. We tested it, we fine-tuned it, we put in these guardrails, we make sure it's safe. We're just taking their words for it. All these top companies. So we need an ecosystem of independent companies that can come in, they can audit the testing of these and verify this is how they perform. We need standard benchmarks for safety. We have standard benchmarks for performance on, writing better paragraphs, for example, or language comprehension. We need benchmarks for safety. To do that, we're going to have to work with government experts. So let's say, for example, that we wanted to test an AI model to figure out, can it help you build a nuclear weapon? Not easy to build a nuclear weapon, but is there knowledge there that might help somebody out? Well, to do that, you actually have to get into classified information that the Department of Energy has. So you've got to work with the government to build those systems. We can't just have anybody testing that. Same thing for biological weapons, right? We have to work with people that are experts in biological weapons to build some of these tests. And then we'll have yardsticks that we can use. And so instead of just saying, I don't know if it's dangerous, we can actually have some clear yardstick we can use that might justify, down the road someday, saying, actually, this is dangerous. And we need to find ways to either make it safer, or we've got to withhold it because you're putting something out in the wild that's maybe not safe.
Yeah. Does that sound almost like an AI FDA? Like, is that sort of what we're talking about?
I mean, that's kind of the model. Look, I mean, we don't just let anybody put any drugs out on the market without proving that they're effective and they're safe first. And we have a process for finding ways to do that. So that's one of the things that people propose is something like a licensing regime, not for everything. You want to write a better app on the iPhone, go forth to do it. But putting in, if you're using the most advanced AI systems, we're talking about tens of thousands, maybe like hundreds of thousands of chips. There's a very small number of companies doing this, that maybe at a certain level, you actually need to have some kind of licensing proving it's safe. We don't let anybody build nuclear reactors, right? Or commercial airliners. There's a lot of technologies that are actually like this. And we find ways to regulate them and use them safely and get their societal benefit and find ways to do both.
Yeah. And that's a good point. You don't want an AI system that's out there and then somebody can ask, how do I build a nuclear weapon? Now, I think maybe that's not the greatest example because there's a lot of resources that go into building a nuclear weapon. And I think you probably can figure out how to build one just from Googling it. But there's maybe plenty of other things that it might be able to find out, especially if it somehow gained access to classified information. Like, would that be the hypothetical? I guess like the model or somebody inputs classified information to it, allowing it to then learn from that and then create a quite the hazard, I suppose. I don't know how to write that into legislation. That's why we need guys like you to help us. So Congress is interested in this. You're right. I don't think interested enough. We have a few people who are smart on this. There is an AI task force that's the bipartisan task force that's led by Jay Obernolte that I think is the right guy to probably lead it, to start exploring some of these things. But I'm concerned. Again, my committee is the committee of jurisdiction on this, and I don't think we've had enough hearings on this. and real conversations. I think there's I think there's a huge lack of understanding at the congressional level. There's been, some guidance put out by each administration, each of the past 3 administrations, but we've got a ways to go. So I hope podcasts like this, which I think a lot of staff listens to, are very helpful. I think I'll leave it there. Paul, thanks for being on. We went well over an hour, so appreciate your patience and time and expertise on this.
Hey, thank you. Thanks for your leadership, both in uniform and in Congress, and especially on these issues. And thanks for having me on. It's great to have a chance to talk with you about this. I really enjoyed it.
It was a great conversation.